Welcome back, future Neb Nerd. In the first module within Chapter 2, we're going to focus on building the foundation and provide you with the Cloud-Defined Storage 101. This module is aimed to provide you with a brief solution overview as well as a thorough product walkthrough. There will be a mix of a few slides as well as a full product demo. Let's get after it. Cloud-Defined Storage is a cloud-managed, SaaS-enabled, on-premises, server-based enterprise storage platform. Cloud-defined storage is defined and managed through a secure cloud-based control plane, which we call Nebulon On, as well as an IoT device which is inside of the customer's application servers in their data center. This is in the form of an integrated PCIe card, which we call a Nebulon Services Processing Unit. Customers are able to network connect multiple SPUs together across their on-prem app servers and compose them into logical groups, which we call NPods. These NPods are able to provide shared or local storage services for applications which run on your servers. Cloud-defined storage is a hypervisor, operating system, and container-agnostic storage platform where we provide data services like compression, deduplication, encryption, snapshot, erasure coding, etc. SPUs are managed and monitored from the secure cloud-based control plane called Nebulon On. Nebulon On is a software as a service offering which provides customers with deep insights in a matter of seconds. This is available for all of your infrastructure globally, and you can view it from anywhere on the planet. There is easily accessible AIOps, self-managed updates, and powerful programmability at any scale. By decoupling the on-prem data plane in the cloud-based control plane, this allows for a much more agile and rich user experience. Think about Gmail or Microsoft 365, for example. New features and updates are regularly rolled out to the cloud without you, the customer, the user, ever even realizing. The same principle applies to cloud-defined storage. Nebulon On allows our developers to introduce new features, machine learning models, APIs, SDKs, views, reporting tools, you name it. And you, the customer, get the benefit without having to ever go through and update device drivers on firmware. Contrast this to what you might be used to today. The on-prem SPUs will periodically require updates. These updates are applied at an NPod level, and they're done in a very fast and easy manner. We'll cover the topic of updates in a subsequent chapter. But for now, that's enough slides. Let's get to the demo. In a web browser, navigate to on.nebulon.com and log into your Nebulon organization with valid credentials. When logging into your company's Nebulon On organization for the first time, users are presented with a one-time end-user license agreement in which your company needs to accept. When logging in for the first time with a newly created user ID in which an admin is created, users are automatically prompted to change their password and re-authenticate. Upon successful login, users are presented with their organization's overview page. The overview page aggregates performance and capacity details at a high level. NPod groups are logical groups and may contain many NPods. In this example, we have development, production, infrastructure, and no SQLDB. In the left nav pane, the aggregation can be changed to more granular views showing all NPods inside the organization. This environment contains 3 single-node VMware clusters and a 4-node NPod which operates a MongoDB NPod. To view specific performance details about an NPod in the left pane, choose the performance card type. This view displays I/O, throughput, and latency details about the aggregation. In this example, the view is aggregated to all NPods. This can then further be filtered down based upon NPod groups within the left pane as well. Very useful. To view specific capacity details, choose the capacity card type. This displays information about the storage capacity and the effectiveness of Nebulon's data reduction technology. This view also leverages the AIOps which runs in the cloud to provide smart and predictive capacity planning. The last card type is application. This view displays specific details related to the VMware vSphere clusters. Notice the NoSQL NPod displays integration not available. This optional NPod configuration item does require read-only access to the vCenter server. The details displayed here consist of CPU and memory of the vSphere host, as well as storage-specific information related to the cloud-defined storage deployment. As we mentioned in the slide section, an NPod relates to an application cluster. It is a best practice to deploy separate NPods for each application. Let's create one together. In the top nav, choose Admin. Under the NPods tab, choose Create. The first section includes the servers which will participate in the endpod. Each server in an endpod must contain Nebulon's IoT endpoint, the services processing unit. Secondly, choose the appropriate configuration template and configure the SPU data interface details. Cloud-defined storage supports IP assignment via DHCP or via static assignment with or without LACP. Just note that LACP is not supported whenever you're leveraging DHCP. Lastly, assign a name and place the endpod in an appropriate endpod group. Before creating the endpod, validation must occur. This is an important step in the pod creation process as it validates that the user attempting to create the pod is able to complete the security triangle. The topic of security is very important and is covered in detail within Chapter 3. Upon successful validation, choose Create. To delete the pod, choose Delete this endpod, and validate by re-entering the name of the endpod. Deletion is completely destructive of all data on the pod and the data encryption key which was created at the time of endpod creation. Data encryption keys are not recoverable and careful consideration should be taken before deleting an endpod. Now let's take a look at an existing endpod. The Basics and Schedules tab displays details related to the template used, including the host operating system, the boot image URL, and the software version of Nebulon which is running on the SPU. The Servers tab includes information related to the physical server itself. The SPU Details tab displays information related to the SPU, including the control and data interface IP addresses. Lastly, the Drives tab displays details related to the physical drives within the server. These areas would not be visited frequently and are very good to know that they exist at least when needed for troubleshooting purposes. Pivoting along to the Volumes tab to display detailed information related to the endpod volumes. This includes operating system boot volumes if the template used to provision the endpod specified one. Boot volumes are easily denoted with the _OS, as well as the data storage volumes are easily denoted here as well. Cruising along to the Snapshots tab where details and a list is displayed related to the volume-based snapshot engine of the endpod. Here, snapshots can be cloned to volumes by choosing the double disk icon on the right side of the screen. Now just give it a meaningful name and choose Clone. And to view this clone, we'll pivot back to the volumes as it is now easy to find the add_hoc volume which was just provisioned from the snapshot, and we can also manage the host and the endpod which the volume is able to be mounted to. Detailed metrics can be viewed through Nebulon on as well. These are made visible within the Metrics tab. The date range can be adjusted to display performance and capacity data for the last hour, 6-hour, day, or week increments. Any previous activity and related alerts can also be found specific to the endpod too. Lastly, the optional application integration with vCenter Server can be entered here too. As previously mentioned, simply provide read-only access to your vCenter Server. This allows the SPUs to forward performance and telemetry data to Nebulon on for consumption. When you back out of the endpod details, previously introduced was the concept of an endpod group. This is a logical grouping of endpods. Typically, it's a line of business or an environment, for example. An endpod can only be a member of a single endpod group. Nebulon On provides a short, curated list of base configuration templates which can be customized to meet an application owner's requirements. The ongoing AI and ML running against customer telemetry data allows the templates to get more specific over time. Now let's take a look at the Esx Configuration Template. Operating system version and application type is defined here, and it's only used for reporting purposes. An endpod configuration template also includes the option to provision both boot and data volumes to all servers within the application endpod. When provisioning data volumes, cloud-defined storage will pre-provision all capacity. For example, if an application cluster contains 4 servers and each server contains 3 terabytes of data, that's 12 terabytes of raw capacity. If a savings factor of 2 to 1 is assumed, an application will be provisioned with 24 terabytes of raw capacity. An important factor to decide upon is whether your application requires single host or multi-host access of the data volumes, or if your application requires data mirroring for additional redundancy and the ability to recover from failed hosts within the pod. The last step within the endpod configuration wizard is to apply a snapshot schedule if appropriate. Cloud-defined storage provides volume-based snapshots which are applied to the pod at the time of creation. We just discussed this. You may use the Python SDK to make alterations after the pod was created. The scheduling is simple. Define a retention policy and an appropriate schedule, and decide whether or not to snapshot the boot volumes or not. A template can include multiple snapshot schedules. Just note that the template is only applied at the time of pod creation. Any changes made to the template after a pod is created are not applied to the existing pod. Essentially, they're versioned. Any new pods created would source from the updated template. The next portion will focus on updating the on-premises data plane of cloud-defined storage. This is done through the software management section of Nebulon On under Admin. Here it is easy to see which pods have recommended updates and are able to be applied en masse. The Activity tab displays the active jobs and can be used in real time to display the task statistics. While the upgrade runs, I'll quickly touch on the huge benefit in which the cloud-defined storage approach provides. By decoupling the data from the control plane, updates are done separately. Nebulon manages the cloud, whereas you, the customer, manage the infrequent and simple data plane updates. With the updates to the pod successfully completed, the last section of the UI includes alerts. Alerts can be received via email notification in real time, via email in the form of a consolidated daily digest, or via a more modern approach, webhooks. Webhooks integrate with collaboration tools like Slack, Teams, or even PagerDuty. In this example here, I have my Slack channel specific for all of my NPod alerts. The last section will focus on user and group management. We get to the user and group management interface through the admin drop-down within the top nav. To create a user, choose Create. Define the appropriate parameters, including email, username, which should be the user's email address, physical name, password, and the appropriate group. Groups define what the user has access to within the environment, and groups have roles as well as scopes associated with them to further pare down access. By default, there are 3 built-in groups: admin, monitor, and operator. To create a new group, choose the User Groups tab and click Create. Give the group a meaningful name and the required role, and then choose Create. Users may be a part of multiple groups. When you are a member of multiple groups, the most permissive right becomes effective. Documentation for Nebulon's cloud-defined storage can be pulled directly through Nebulon On too. For customers who are deploying cloud-defined storage with Kubernetes, visit the Nebulon GitHub site at github.com/Nebulon and then choose Helm charts. For customers who are interested in the Python SDK, you can pip install NebPy client, and for the SDK documentation, choose the documentation link at the bottom of the README. That wraps up the Foundations module within Chapter 2. Next, we'll focus on Day 1 tasks like installation, cabling, and network connectivity. Feel free to take a break if needed. Otherwise, join me in the next module.